Okay. All right, so let's talk about anchor points. So what I want you to do when you're graphing these, I want you to graph the vertex and one point on either side of the vertex. Okay, now let's look at the parent function right here. So when we graph the parent function, we graph our vertex right here, and then look, we have some points right here, right? And to get those points, we moved over 1, up 1, over 1, up 1. Okay, that's kind of like the shape of our parent function. Okay, so that's y equals x squared. We move over 1, up 1. Okay, what if it was y equals 3x squared? Then, if this is our function we're graphing now, we still have our vertex, but now we're going to move over 1, up 3. 1, 2, 3, right here. Over 1, up 1, 2, 3, right there. Okay, so then we would have this, and that's why it looks skinnier. Okay, y equals 3x looks 3x squared looks skinnier. So the reason that I'm showing you this is so that you can see that this value right here, this number in front of the x squared, that's our scale factor, right? It's how much we're stretching or shrinking by. And so that's going to affect our points on either side of the vertex. So let's go down here at this one right here. What is a in this case? Okay, a is the number right here in front, but there isn't one, right? So there's just 1. There's an invisible 1. So a is 1. Okay, a is 1. So that means that this graph is not going to be stretched or shrunk compared to the parent function. It's going to be the exact same shape. Okay, so that means that if we start at the vertex right here, if it's the same shape as the parent function, I go over 1, up 1. Okay, on either side. So over 1, up 1. Okay, so now I'm going to call that good. I'm going to say you just need to plot 3 points, the vertex and a point on either side. So I'm going to draw my parabola now. Okay, that's what it looks like. Okay, so what were my anchor points? Well, because a equals 1, or because, yeah, in this particular function, a equals 1. So that means I'm going to, from the vertex, so from vertex, I'm going to move right 1 and up 1 and left 1 and up 1. Okay, isn't that what I did? I moved right 1, up 1, left 1, up 1. That's how I got my anchor points. Okay, so but if I had like a 3 out front, okay, say I had a 3 out front, then I would have to go over 1, up 3 and left 1, up 3, right? Because it would be skinnier. Okay, I'll erase those because I don't have a 3 out front. Okay, I only have a 1 out front. Okay, but basically how we find these anchor points, so I'm going to go up here, you can fill this in right here. How we find these anchor points, so from the vertex, we're going to move right 1, and we're going to move up or down based on what A is. Okay, and then I'm going to move left 1, and I'm going to move up or down based on what A is. Okay, again, this is something that when we get more practice, it'll make more sense. Okay, all right. By the way, max and min, like you guys know this already. We've talked about this, right? If it's reflected like that, it has a max value. If it's this U shape like this, it has a minimum value. Okay? Okay, so this graph right here, does this have a max or a min? Well, it's the U shape, the vertex is right here, so it has a minimum. So I'm just going to circle that. Okay, it goes up forever and ever, so there's no max value, but there is a minimum value. Okay, now let's compare it to our parent function. Is there a horizontal shift? Have we moved left or right? Yes. Okay, we moved left 4. We already determined that, so I'm going to say left 4. Is there a vertical shift? Did we move up or down? Yes, we moved down 1. Down 1. Is there a reflection? Well, is there a negative out front? No, so that means there's no reflection. What's the stretch or shrink factor? It's just 1. It's A right there, okay? So it didn't really stretch or shrink at all. The factor is just 1. Okay? All right, so we've seen an example now. Let's do a couple more examples. Okay, so these ones I'll go through a little bit faster since we have gotten some practice, but we'll still take some time. Okay, so let's look at this function right here. Now, what is A? See that number right there out front? That's A. So you can ask yourself, is this going to be stretched or is it going to be shrunk? Well, 1/2 is smaller than 1, so it's actually going to be shrunk, right? So that means that the function's probably going to be kind of wide instead of skinny. Okay? All right. What happened right here? Does that move us left or right? See if you can kind of answer in your head. Okay, it's a +3, so that means we went left 3. Okay? All right, and then the +4, we've seen those before. That means we went up 4. Okay? All right, so what's the vertex? Well, remember, the h value, our vertex is hk, but we have to take like the opposite sign of whatever we see in here for the x value. So since this is +3, that means I went left 3. Okay, so my vertex is actually going to have a -3 right here. And then I went up 4, so I'm going to have a 4. Okay, because if I look at my graph, I went left 3, 1, 2, 3, up 4. 1, 2, 3, 4. That's my vertex. Okay, -3, 4. So I have to just look at my equation. I take whatever the opposite sign of this is. So that means h is -3, and then whatever the sign of that is. So k is 4. Okay, so I just have to swap the sign of the one attached to the x. All right. Okay, so we've got our vertex. What's our axis of symmetry? Well, our axis of symmetry always goes through the vertex. Okay, it's going to go right here. Remember, that's my graph is going to be a mirror image across that. And that happens right here at -3, right? That's what this spot is on the x-axis. Okay, so it's going to be x equals -3. And notice how these always match. Okay, now let's do our anchor points. Okay, our anchor points. Now to get our anchor points, we're going to go left and right 1 from either side of the vertex, and we're going to go up and down depending on what A is. Okay, well down here, A is -1/2. Okay, so we have a 1/2, but negative means we flipped it down. We went down instead of up. Okay, all right, so our anchor points, that means we're going to go from the vertex. I'm going to go right 1 and down 1/2 and left 1 and down 1/2. Okay, if the way I'm writing this like totally doesn't make sense, like, I mean, that doesn't really matter. That's just kind of my shorthand way of writing it down. But basically just look at the graph and say, okay, when we move in either direction, the parent function normally goes over 1 up 1, right? But I have a 1/2 for A. So instead of going over 1 up 1, I'm only going to go a half. And I'm going to go down instead of up because it's been a reflection. Okay, so I'm still going to go over 1. But instead of up 1, I'm only going to go a half, and I'm going to go down instead of up. And the down is just because of the reflection. Okay, so the 1/2 is because my A value is 1/2. And the down is because of the reflection. Okay, so again, let's go on this side. This side 1, and let's go down. But let's only go down 1/2. Okay, and then I can draw my parabola. Okay, so it's a little wider than the parent function. Okay, and it's going to be a max. So you can circle that. Okay, all right, so let's compare to our parent function. Has there been a horizontal shift? Have I moved left or right? Yes, I moved left 3. Okay, so left 3. Did I move up and down? Yep, I moved up 4. Was there a reflection? Yes, because there's a negative right there. Okay, that's why I went down instead of up with my anchor points. Okay, so yes. Was there a stretch or a shrink factor? Yeah, this was a shrink, okay, of 1/2. So you can write 1/2 or negative 1/2. Okay, I really just care if you recognize the 1/2. Okay, what's the domain and range? Well, this is a parabola. The domain is negative infinity to infinity. The range, remember we're looking at the y-axis. Okay, remember this graph goes on forever and ever going down. So our range is going to go from negative infinity, because when I start down here at negative infinity, there's going to be like a shadow on my y-axis, right? And where does it end? At 4. Okay, let's write the interval increasing, decreasing. This is actually a review. Okay. All right, so if I move along my x-axis, I'm going to start at negative infinity over here and go to infinity. If I move across my x-axis at negative infinity, is my graph increasing or decreasing? Well, it's going up. See, it's increasing. It increases. So it's going to increase all the way until we get to here, right? -3. Okay, so from negative infinity all the way to -3, my graph was going up. Okay, so it's increasing from negative infinity to -3. And then the rest of the way, it's going to decrease. It's going down. I should have done that in a different color. It's going down. Okay, so as I'm here at -3, as I move towards infinity, my graph is going down. Okay, so from -3 to infinity, my graph is decreasing. Okay, and that's how we graph that one. Okay, so let's do our last one. Okay, so let's look at this function right here. Let's see what's happened. This 3 right here means we're going to stretch by a factor of 3 because 3 is bigger than 1. We don't have a negative out front, so there's not going to be a reflection. Okay, and then this -2 right here that's attached to the x, that means I'm going to go right 2. Okay, and then this +2 at the end, that means I'm going to go up 2. Okay, so some of this stuff I can fill out. Horizontal shift, yeah, I know I'm going to go right 2. Vertical shift, I know I'm going to go up 2. Reflection, no, there's no negative out front. Stretch or shrink factor, 3. Okay, so we filled out some of that. All right, let's do the vertex. Okay, see if you can write down the vertex right now by yourself. Okay, the vertex is going to be 2, 2. Okay, because I need to take the opposite sign of this one. Since that's a -2, I'm going to have a +2 right there. Okay, and then I'm going to take the same sign of this one. I have a +2, so I'm going to put a +2. Okay, because I went right 2, up 2. Okay, so my vertex is going to be right there. Okay, all right, where's my axis of symmetry? Well, it goes through the vertex right there. Okay, and that is going to be at x equals, that's kind of thick. It's going to be at x equals 2. Again, these match. All right, my anchor points. Okay, let's look at this A right here. A is 3. A equals 3. That's how I get my anchor points, okay? A equals 3. That's important for my anchor points, okay? So I'm going to start at my vertex. I'm going to go over 1 on both sides. I always do that, over 1 on both sides. How many am I going to go up or down? On the parent function, I only go up 1. But because this is a 3, I'm going to go up 3. So we're going to go up 1, 2, 3. So I'm going to have a point right here. Okay, same thing on the left. I went over 1, I went up 1, 2, 3. Put my point right there. Okay, and now I'm ready to draw my parabola. So see how it's kind of skinny? That's because of the 3 out front. Okay, so my anchor points. So if you want to remember, we went right 1 and left 1. We do that every time. So we went right 1, we went up 3, and left 1, up 3. That's because, so we're always going to go right and left 1 to either side. But in this example, since it was a -1/2, we went down 1/2. In this example, since it was a +3, we went up 3. So it depends on what your A value is. Okay, now this is a U opening up, so we're going to have a minimum right there. Okay, what's our domain? Our domain is negative infinity to infinity. Our range, as we move up the y-axis from negative infinity to infinity, okay, we don't see anything until right here at 2. So it's from 2 all the way up to infinity. That's what our range is. 2 to infinity. Okay, increasing and decreasing. Well, again, we move on the x-axis from negative infinity to infinity. So as I move this way, my graph is decreasing, it's going down. And it's doing that clear until I get to 2 right here. Okay, so from negative infinity to 2, my graph is, oh, sorry, that's increasing. Okay, from negative infinity to 2, my graph is decreasing. And then it's increasing after that. So see, it's going up the rest of that way. So from 2 to infinity, it's increasing. Okay, all right, so those are the notes for today. So that's vertex form. So basically, we've learned how to graph quadratic functions in a couple different ways. So vertex form is when you kind of see this shift in attached to the x. Okay, so that's where we kind of saw this number attached to the x. We're going to use the method from this section. Okay, and if we don't see a number attached to the x, we're going to use the method from last section. Okay, so see how we just kind of had, this was just written in a totally different form. We have an x squared here and an x here. Okay, if you see something that looks like this, you're going to use this method from these notes. Okay, all right, so work on your assignment now. So if we go to our assignment, let me explain. I think there's some I don't need you to do. Okay, so if you go to 3.4a, there's a 3.4a and 3.4b assignment. If you go to 3.4a, there's a bunch of graphing practice. I want you to work through all of these. This is going to be the most important. Okay, so work through this graphing practice as best as you can. Julie can help you. I can help you on Monday. Help each other. Okay, work through this graphing practice. It's the exact same as the notes, except this doesn't like guide you through the steps. So just do the same thing we did on the notes. Okay, and when you get to the end of here, I want you to do all of these 13 through 16. I don't need you to do 17 through 20. Okay, so you can cross out 17 through 20. Okay, so on 3.4a, do everything 1 through 16. Okay, that'll probably take you till the end of class. But we're also going to do 3.4b right here. Okay, there's more graphing practice, so kind of do these ones if you feel like you need more practice, but I would focus on 9 through 13. I do want you to do 9 through 13, okay? And you don't need to do any of the rest of it. Okay, all right. So start on 3.4a, get some graphing practice, and I will see you on Monday.